In our last movie, we created capture properties to create a diff pair construction. Since they're capture properties and we apply them to nets, they apply to all layers in the stackup. In this movie, we'll create physical CSets by layer for differential pairs. We'll have different types of diff pair constructions on different layers of the board to reflect different dielectrics, different regions of the board, and different differential impedances. Our first step is to get into the Define Physical screen to create CSets by layers. I've back annotated from my BRD file, so I have the default physical CSet that includes the stackup information. I'll select any cell under Physical CSet and right mouse click, and then from there go into the Define Physical. I'll select Define Physical CSet, and I'll call this Diff1. There's our new Diff1 CSet. And to work on differential pairs using the VISUEYES feature for CSets, I'll scroll over till I find one of the differential properties, putting my cursor under that property and right mouse clicking the differential CSet screen. The VISUEYES differential screen for defining physical CSets by layer has several sections. There's a window here divided into fields for creating the construction of the differential pair. There's the different layers for applying that construction. And in the VISUEYES screen, we have two views. We have an All Layers view, and we have a differential pair builder view that you'll see in just a minute because I've selected Auto Show Builder View on. I'll move my cursor into the fields to create my differential pair construction that I want to apply to the outer layers. As soon as I put my cursor into the first field, the Auto Show Builder view will shift over to the Diff Pair Builder view. I'll zoom in. And I'll start creating my diff pair construction that I want to use. I'll put in a width of 12 and a gap of 15 and a neck width of 8 and a neck gap of 8 and a minimum space of 8. And I can see in the VISUEYES screen in the Diff Pair Builder view what that differential pair is going to look like. Now, holding my Control key, I'll select the top layer, the bottom layer, and I can see that I've created this differential pair construction and applied it to the outer layers for my differential pair physical CSet. I'll do the same for the internal layers and create two more different constructions and apply them. We've now created the physical CSet that we need to describe the different differential layer constructions on different layers throughout the stackup in order to have different impedances in the different regions of the board. I have my Diffpair objects defined, and I could go into the constraint window and right mouse click on Physical CSets and simply apply the Diff1 Physical CSet to the differential pair objects. But there are other ways to do this within the constraint window, so I'm going to show you that right now. I'll go down to, under Physical Properties, Diff Pairs. I'll pick a diff pair property. This opens the same visualized differential screens that we saw when we applied standard properties to all layers in the capture property system. Only this time we're going to apply CSets from this screen and see how that works. Since we've already got our diff pairs defined, I'll choose all of our pairs to populate the screen. I'll select all the pairs, and now I'll select the tab Available CSets, and we can see the default and the Diff1 physical CSets that we have in the system that could be applied to the differential pairs that we've selected. If I highlight Default, I'll see the 3D cross-sectional stack-up view of the default CSet applied for these differential pairs. And if I select Diff1, I'll see the differential physical CSet by layer that we just created. If there were a lot of different physical CSets that could be applied to differential objects, I'd be able to select each one here and see what its cross-sectional 3D view looked like to be sure I was applying the correct physical CSet to the right differential objects. The VISUEYES system is here to help you verify visually that you're applying the correct geometries that you intend to. The Diff1 CSet is the one we want to apply. And now I'll select Apply CSet to select the differential pairs. I'll go back to the differential pair tab, and I'll say Save. The Diff1 physical CSet by layer has been applied to our nets the same as it would be if we had done this directly in the constraint window. And if we go back and look in the constraint window, we'll see that there it is. It's been applied, but we use this approach in order to be able to see the physical CSet by layer before we applied it. And look at our property editor. We'll see our differential pair object and our physical CSet Diff1 applied to all the nets. In our next movie, we'll introduce classes, class-to-class, spacing CSets for crosstalk and crosstalk by layer, interbus crosstalk control, and intrabus using DDR nets as an example.